Number 14. By considering but not calculating the slope of the tangent line, give the derivative of the following. Complete parts A through E. Well, part A is f of x equals 6. So think about what that means. Y equals 6 is a horizontal line through 6 on the y-axis. So how is this line changing from point to point? Well, no matter where you pick, there's no rise. So this derivative, no matter what point you pick, will be 0 because there's no change anywhere on this. Now later on, we're going to learn that if f of x equals a constant or a number, we'll just say C, a number, then f prime of x is always going to be 0. So we don't have to do the formula if it's a constant. The derivative will be 0 for that function if it's a constant function. Part B, f of x equals x. Now this is a line where y and x are equal, like 0, 0, 1, 1, 2, 2, 3, 3. So this is a line that looks like this. And no matter where you are on that line, it's changing by 1. So the derivative of this is 1 because its slope is 1. Now you're going to learn later on that if f of x equals x, f prime of x equals 1. And if f of x equals 2x, f prime of x equals 2. It's just the slope of the line. So we can apply the same thing to letter C. F of x equals negative x, right? If you got x and f of x, where this is 1, negative 1, 2, negative 2, 3, negative 3, your points are going to go like this. So that's a line with a slope of negative 1, and we can apply this same strategy from up here. If f of x equals c times x, where c is a number, f prime of x is always going to be c. So in this case, it'll be negative 1. The line x equals 3, well, that's not a function. That is a vertical line, okay? And since it's not a function, the derivative does not exist. And the last one, the line y equals mx plus b. The derivative is going to be m. Using the same logic from up here, we've got this. We've got f of x equals cx plus c, well, that's a number, and that's a number. So the derivative of that is 0, the derivative of that is c, and c plus 0 would be c. So m is our coefficient, and that's going to be our derivative.